Hello guys, welcome back to the channel. Today we're checking out something super useful for Arduino project, and this is wireless communication using the nRF24L01 modules. These little guys, a transmitter and a receiver, let you send data wirelessly, which is perfect for robots, remote control, and tons of other cool stuff. So in this video, I'm going to show you how they work, how to set them up, and even how to fix the common issues. So before jumping to the video, if you love DIY electronics and Arduino projects, consider hitting that subscribe button. It really helps the channel and keeps me motivated to make more content like this. Alright, let's get started. This tiny little module is a wireless transceiver, meaning you can both send and receive data. It operates on a 2.4 GHz frequency, which is the same frequency as Wi-Fi, but way similar in lower power. It's a great alternative to Bluetooth and RF modules, especially for long range and lower power projects. The nRF24L01 connects to Arduino using SPI protocol. Basically, it acts like a wireless messenger. One module sends data and the other receives it. It supports up to 125 different channels and can communicate with multiple devices at once. Why do we use it instead of Bluetooth? Yeah, good question. Bluetooth is great for short-range communication, but it has limitations. It's power hungry and connecting devices can be a hassle. The nRF24L01 can go way farther, up to 100 meters in open space, and if you upgrade to the BA or LNA version, it can burst that range even further, up to 1 kilometer with the right antenna. Let's talk about the joystick. A joystick is basically a simple inbuilt device that lets us control the movement in two directions, the X-axis and the Y-axis. Inside the joystick, it has two potentiometers which measure the precision of the stick and convert it into electrical signal. How does it work? When the joystick is centered, both X and Y values are around 500 out of 123. But when you push it forward, the Y value increases towards 123. When you put it back, the Y will decrease it towards 0. When you move left or right, the X value changes in the same way. There are also the button inside. If you press the joystick down, it starts like a simple push button, which can be used to trigger extra functions like switching modes or activating lights. Well, for this project, I will choose the Arduino Nano board instead of the Uno board, because first of all, it's tiny. If you're building something compact like a small robot or wearable devices, the Nano fits way better. Even though it's smaller, it still has the same chip and features as the Uno, but it's also cheaper and it can be soldered directly onto the PCB. Plus, it uses a mini USB instead of a big Type B port, making wiring easier. So if you need something light, compact, and budget friendly, the Nano is the best choice. So first, we will have the GND, which is the grounding, and it's easy to spot because it's usually marked with a square badge on module. Always connect this to the GND on the Arduino board. Next, we will have the VCC, which is the power supply. Be careful here because the nRF24L01 only works with a 1.9 volt to 3.9 volt. This is not 5 volt current. On the Arduino Nano, connect this to the pin 3.3 volt, not 5 volt, or you risk damaging the module. The CE, which is chip enable, this is active high beam. When you set high, the module transmit or receive data depending on its mode. We typically connect this to pin 9 on the Nano. The the CSN or chip select node. This is an active low band. The SCI bus uses it to select the nRF24L01 as the active device. It usually connects to pin 9 on the Nano. The SCK or the clock ring, this pin receives the clock signal from the SCI bus master, which is the Arduino, connected to the D13 SCK pin. Next, we will have the MOSI, which is a master out slave in. This is the data input from the nRF24L01. It gets data from the Arduino and should be connected to the pin 11. The pin MISO, master in slave out. This is the data output from the nRF24L01, sending data back to the Arduino, connected to the pin 12. And the last one is the IRQ, interrupt output. This is the optional pin. Let me open the serial monitor. So this is basically the value of the X axis and the Y axis. So when you move the joystick, the value will change. For example, if I move forward, the value will be 123. Backwards, to the left, you can see that the value of the X and the Y axis change like this. So based on the value, is going to send it into the RS, and the RS will control the motors based on the signals. So let's see how it works. Press, the value will change continuously. See that? Okay, so let's come to the RS code, and we are going to open the serial monitor. Have a look. And it's gonna bring the X and Y axis to the serial monitor like this. This is the function that converts the